started. Okay, today we are studying functions. Yesterday your assignment was to finish this slide, so check yours and check it against mine. Make sure you did everything correctly. I did get called out because this was incorrect. It was not listed from least to greatest, but I fixed it, Abby Kate. I fixed it. And then on the X's and Y's on the mapping on this one, see how 3 goes to 3 and 4 goes to 3?
Isn't that repeating? That's bad.
That means that the Y's repeat. The X's did not repeat, though. But that's something we're going to talk about today. So check this, change it, correct it. Now let's go on to 2.2, which is functions. So we are going to write the definition of a function. So yesterday y'all wrote out what a function is. On your Quizlet, what was the definition of function? I don't remember.
I have the English actually.
Okay, pull it out. Let's look at it.
The definition of function is a relation in which each element of the domain is paired with exactly one element of the range.
Okay. Well, we're not writing it. We are going to copy and paste it from the Quizlet. That would be an easy way, right? Okay, so let's see. The Quizlet was on Google Classroom. It was from right here, Monday. So once you get to it, let's find function, domain, range, continuous function, discrete. It's the last one. Okay. So I believe you can copy it and paste it over here. If you can't copy and paste it, then you will have to type it. There we go. A relation in which every element of the domain is paired with exactly every element of the range. So I do want to add something in here next to domain. What is domain? What values? X values. And what about the range? Y values. Okay, the characteristics is next. I did not close my parentheses there. There we go. And then the characteristics for function, X values. Oh, I did not like that. I'm going to do a different font. X values cannot repeat. If the X values repeat, it's not a function. And on a graph, use the vertical line test. Y'all remember that? If the vertical line passes through more than 1 point, then it is not a function. It should only touch the function once. Okay, so I have some examples here, and we are going to drag them over to the example side or the non-example side. So here's the first one. X values 1, 2, 3. Y values 2, 4, 6. The X values are not repeating. So it is an example. Make it a little bigger if you want. The next one, I'm going to make it bigger so we can look at it a little better. If I were to draw vertical lines down it, or just run my mouse up and down, then it only passes through the function once. So it is a function. It is an example of a function. Make sure you pull on the corner so you don't distort it. Okay, let's do this next one. Make it a little bigger so we can look at it. Okay, if I were to run a vertical line straight up and down all the way through, my first vertical line, it passes through right here and right here. So this is not a function. It is a non-example. Okay, the next one, let's look at these ordered pairs. So we are looking for x's not to not repeat. So let's look at just the x values. So 1, 2, 3, 4, 5. X values are not repeating. So that means it is a function. Okay, let's look at the next one. Let's look at the x values, which is also called the input. 4, 1, 0, 1. Uh-oh. 1 is repeating. 1 is with -1 and 1 is with 1. X values cannot be with more than one y value. And also 4. 4 is with 2 and 4 is with -2. So this is a non-example. Okay, the next one, this mapping. So we are looking, I need to move this over, to see that x values don't repeat. 1 is matching with 3 and 1 is matching with 4. That means that 1 is repeating. So this is a non-example. We're done with this slide. Let's go on to the next slide. I think these were supposed to be here. Delete these. It was supposed to be on a different slide. Okay, this is just information. Okay, identifying functions. A function is a relation where each input, remember input is your x value, produces exactly one output. Input values are x, is our domain. Output values are the range. Identify it with a table. So you're looking to make sure that x values do not repeat. So here we have the x values 4, 7, 8, 12. They're not repeating. But on table 2, we have 3. 3 is matched with 6, and 3 is matched with 9. So that is not a function. Here's an example of the vertical line test. Let's see. I'm going to zoom in. Can y'all see it pretty good on your screen? The vertical line test. Okay, well, graph the relation, and if any vertical line only passes through its graph once, it is a function. So this is a function. This is not a function. A circle is not a function. And this is a function. And then with ordered pairs, you're looking to make sure that the x values do not repeat. The x's are the first numbers in each ordered pair. So this is a function, and this one is not, because 0, 0. 0 matches with 2, and 0 matches with 4. Domain and range, you're looking to see that it does not repeat. Okay. Let me fit. Okay, let's look at some examples. Function or not from ordered pairs. So you're going to drag the terms to identify if the relation is a function or not a function. Control C to copy. So I'm going to pause it, and I'm going to let you do actually 11, 12, and 13. Okay, so you should be done by now. So let's look at each one, and y'all help me out. The first one, function or not? Function, okay. The next one? Not a function. Okay, the next one? And the next one? What? Okay, it's a function. 4, -2, 2, 0. Okay. Then the next one? Not a function. Okay. There we go. All right, let's look at the vertical line test. We can actually use vertical lines on here to do the vertical line test. I'm going to draw some vertical lines with, let's see, red. For this first one, I just made a line, changed it to red, and I'm copying and pasting it multiple times. Okay, so the first one, it only passes through the vertical line one time, so this is a function. Okay, this next one, let's see. And if at any point, and it doesn't have to go through a point, it can go through a line. This is called continuous because it continues from one point to another. So it can be at any point during the function's graph. So even though this one looks like, well, it goes down, so it continues on. So then this one is a function too. Okay. And I'm using Control C and Control V constantly on here.
So if you saw some Y's yes. can repeat, but the X can't?
That's correct. Yep. Y's can repeat. Okay, the next one. Oh, I gotta put this down here. Need to grab a line. Control C, Control V. And what do you notice about this one right away? It's going to go through. It's not passing the vertical line test, so it's not a function. Okay, the next one, let's get this vertical line, Control C, Control V. Is it going to pass through more than once? Yeah, it is. So at this point, it passes through more than one time. So that makes it not a function. Okay, the next one, I need to grab one of these lines. Control C, Control V. Okay, what about this? This is an open circle. This is, open down here and closed here. What does that mean? This is just like when we graphed our inequalities. Is this open circle included as a point? No. But is this closed circle included as a point? Yes. So this is okay because this is not included. It's everything up into -1. This one includes that point. And then over here, same thing. This goes through a point. This one is open, meaning it's not included. So this is a function. Okay, the last thing is the mappings. And I messed this up on accident. So what I'm going to have y'all do is I'm going to go to Slide, Edit Master. And it opens this up in a different type of screen. Now, everybody do this. I was on that slide. I went to Slide, Edit Master. Slide, Edit Master. And now it looks like this. It has a border around it. Now I want you to click on this one because these are the exact same. Double click on it. And there's another problem over here. I just need to slide this over to get that problem inside that box. Because I cropped it into the wrong problem. So I want the one that says 12, 13, 14, 10, 9, 8, 7. And now click out of the box and it should be there. Now do you see? If you need to crop it again, go to double click it. And then you can adjust it as needed. So I need to actually pull this out a little bit. Like that. All right, so now click on the X. And now you're back to the original. Or not the original, but the correct slide that we're supposed to be on. Was everybody able to do that? Okay. So let's look at these mappings. So this is 1 matches with 7, 2 matches with 8, 3 matches with 6, 4 matches with 7. Do the X values repeat at all?
No.
No, so it is a function. Okay, the next one, 12 matches with 9, 13 with 10, 13 with 7, 14 with 8. Which X value repeats? 13, because it goes to both 10 and 7. Okay, so we are finished with our notes. You're going to use these notes as you do the assignment. So let me show you what the assignment is. It says functions, drag and drop. So click on it. And click View Assignments. And this is the assignment right here. So let's read the instructions. Function or not card sort, student directions. On the 3 slides, you'll see 24 relations labeled A through X. On a sheet of notebook paper, write the letters A through X. Determine whether or not each relation is a function or not, and write it beside the corresponding letter on your notebook. When you're finished, go to slide 5. Drag and drop the letters into the correct category for function or not a function. When you're done, this said something else. It said share it back to your teacher, but y'all are just turning it on Google Classroom since I assigned it to you. So here are the things that you're looking at, the functions or not a functions. So go ahead and work on this. And if you want to, you can write function or not a function on here instead of writing it on paper. It's up to you. You can do it completely digital. And then drag and drop. This is what I'll be checking. So put these in alphabetical order. So like A, you'll put first, either on function or not a function. Put them in alphabetical order going down in a like a column. All right. And that is due tomorrow.